Hello, my name is Santiago Calderon Contreras and I am civil engineering student at the University of La Salle. I have come to talk about the article called geopolymer mortar based on sugar ash cane that incorporates propylene fibers. In the introduction, he defined concrete as one of the most used materials worldwide, but that consumes raw materials and energy that cause CO2 emissions. The cement industry contributes 5 to 8 of emissions worldwide. Therefore, the researchers strategies to reduce these emissions and that create new materials that are friendly to the planet. Okay, sugar ash has important since it not only reduces CO2 emissions but can also improve the performance of cement mortar by adding a head to resist traction stresses more. You can also use corn ash, rice ash, and manufactured paper ash, among others. The objective of these researchers is to use sugar ash as wasted to reduce cement productions and improve physical properties in a sustainable way. As a methodology, we have 9 steps. The first is a taking of the sample which heat treated in a muffle furnace for 2 hours at 900 degrees centigrade. Then it is left to dry in the open air and is taken to a ceramic mortar to be crushed until we find the same thickness as cement. The second step is to make an X-ray fluorescence. With it was found that the predominant element is a sun. The third step is to scan with the electron microscope to detect the morphology of the particles, which were angular in shape. The fourth step is the manufacture of the two-stage geopolymer concrete, in which alkaline activators, fibers, and viscosity reducing agent and surface saturate natural rubber sand are used. The 5 steps is to make 5 mixtures on the of modified cement and 4 of geopolymer components to be compared. The cement ratio is 1 to 1.5 and the geopolymer is the very thin the amount of fiber element. The last steps consist of making the joints, let them melt, dry and oven for 24 hours and cure in the same oven but 25 degrees and humidity of 15%. Final tests are carried on our 7, 14 and 28 days using destructive and non-destructive methods. In results and discussions, it was found that the polymer has dense and homogeneous microstructure, which indicates that it has fewer pores and it was observed that at any age in the joints, the humidity has to increase it according to the amount of fibers. That is, the more fibers, the more water absorption will have. It was also analyzed that the compressive strength and tensile strength were analyzed as a function on the age of the sample, which shows the lower the age, the strength will increase. As an important result of the research, I can be said that the sugarcane bagagh geopolymer gained 75% of ultimate compressive strength in the first 7 days, which indicates that it gains in higher percentage if of its maximum strength in early age, which indicates that this iteration is faster compared to simple cement. As conclusions, we have that finally ground bagagh has proved some of silicates that reactive with silicon activators of temperature of 60 degrees Celsius to obtain well-extracted geopolymer compound. I can also be concluded that the resistance of 60% was achieved when the sample were cured with heat for 24 hours in no route and an air curing of 7 days in air. It was also found that the dose perfect fiber property was 1% as a function of the water absorption, which means that by addition only this amount the mixture will give us an excellent result. Finally, the sugarcane bagagh ash can be an option to reduce the use of cement signs. It has a bibliography, it has a great variety, and that will be it. And thanks for you very much.